Welcome to Get Your FRQ On. This question is from 2006, Test B. It's question 5, and it is not calculator active. In the question stem, we're given a differential equation, and in part A of the question, we are asked to sketch the slope field for the 9 points provided. With any slope field question, you're going to want to use the differential equation to determine the slope at the given points. So the differential equation, dy dx equals y minus 1 squared times cosine of pi x. Notice that when y is equal to 1, the slope will always be 0. That simplifies this a bit, and then just use, if y is equal to 0, negative 1 squared is 1. So if y is equal to 0, you're really just finding the value of cosine pi x. Once you have the slopes, sketch the slope field. This is what we get. In part B of this question, find the value of c if y equals c solves the differential equation. All right, so keep in mind this is asking about a specific function y equals c, which happens to be a horizontal line. All right, so by saying that if y equals c solves the differential equation, what we're getting at here is that there is a horizontal line, y equals c, that solves the equation. But because it's a horizontal line, the slope must be 0. So we're looking for values of c that I could substitute in for y, where dy dx would always evaluate to 0. All right, this is going to happen when y is equal to 1, because if y is equal to 1, 1 minus 1 is 0, 0 squared is 0, and then it won't matter what the value of cosine pi x is. So let c equal 1. In part C of this question, we are asked to find the particular solution y equals f of x using the initial condition that f of 1 is equal to 0. Using separation of variables here, as would be the expectation, we get dy dx equals y minus 1 squared cosine pi x implies that dy over y minus 1 squared is equal to cosine pi x dx. And then we just anti-differentiate both sides. After anti-differentiating both sides, we get negative 1 over y minus 1 equals 1 over pi times the sine of pi x plus a constant. I'm going to multiply through by negative 1 just because I don't want the negative on that side. I am going to try to solve for y. So if I multiply by negative 1, I get 1 over y minus 1 equals negative 1 over pi times the sine of pi x plus the constant. Using that initial condition to solve for c, that is plugging 1 in for x and 0 in for y, we can solve for c. 1 over 0 minus 1 equals negative 1 over pi times the sine of pi plus the constant is equivalent to negative 1 equals negative 1 over pi times the sine of pi plus the constant, but the sine of pi is 0. So that term cancels out, and then we just get c equals negative 1. All right, substituting negative 1 in for c and then solving for y, we get y equals 1 plus 1 over negative 1 over pi times the sine of pi x minus 1. You really don't have to worry about simplifying this. As long as it's correct, you should get whatever points are allotted for having the solution here. Don't feel the need to have to figure out what that is equal to in some form that might look prettier. You don't have to do that.